Number 26. Find the inverse to the equation f of x equals square root of 2x all over 3 plus 1. All right, so first, if we're going to find inverse, the thing we need to remember is that inverse means that we need to switch our x and y, or switch x's and y's if they're plural, so I'll put that there. That's the whole technique here. So f of x represents our y, and so I'm going to switch those two and say that x equals the square root of 2y over 3 plus 1. And now, that was my first step, is to switch x and y. Your second step is to solve for y. So if I'm going to solve for y, I first need to move the stuff on the outside, so I subtract 1 from both sides. This leaves me with x minus 1 equals square root of 2y over 3. Now, I'm still trying to get the y by itself. Let's get rid of this fraction. I do that by multiplying by 3. And so if you multiply, you need to multiply everything. So those go away over here. Those simplify out. And so I'll distribute this. I have 3x minus 3 equals the square root of 2y. To get rid of the square root, I need to square both sides. So this gets squared. This also gets squared. So now I have 3x minus 3 equals 2y because these simplified out. The last thing to do to get rid of that 2 there is we're going to divide it. This is multiplying times y right now. And divide it. And that will give me my equation. Now, we don't typically just write it as y. Since this is called f, we would call it f negative 1 of x, or just f negative 1. You can say this equals, I forgot the square here. I'm sorry. That was squared. And so I'm going to rewrite this as the way we normally would write it. It's 1/2 times 3x to the 1/3 squared, just like this. That 1/2, I got that because I'm saying that's 1 over 2 there. And so I just rewrote it as 1/2. And this would be my equation here. Now we can check this answer out in the calculator. I'll show you this. There's 3 techniques that I usually use when doing an inverse. This is one of them. The algebra is you switch x and y and solve for y. Graphically speaking, what we could do is if I go over here, I'm going to add a graph. And I'll graph that first equation, which was the square root of 2x over 3 plus 1. Okay, here's your second technique. You graph the original equation, and then you type menu, actions, text, and now we just switch x and y. This is my y, so instead of y, I'll say x equals square root and 2y. I forgot to do the fraction. Let's see if it'll still let me here. I might need to hold down shift here and highlight this and let me get a fraction. Let's see if I get it. Hey, there we go. Over 3 plus 1. This is the x equals phi technique, basically. Instead of saying f1 of y, this represents f1. You could do f1 of y. I just typed in the whole thing, and I drag it to the axis, and there it graphs it. That's the answer I'm looking for. Notice the domain is restricted from 1 to infinity. Now let's type in our answer. We said the answer is 1/2. Calculator's going crazy. Here we go. 1/2. 1/2 3x minus 3 quantity squared. Press enter. You'll see that's our graph there. Now, how is that related to what the calculator said should be the inverse? When I check them out, you can see how the one in red goes right on top of what it was supposed to be. So we did find the right answer. We just need to restrict the domain. That's what you call this. So we need to say the domain needs to be restricted to, we said that domain was from 1 to infinity. And the way you really restrict domain, if you want to do range, it was 0 to infinity. The way to properly do that is you look at the first graph, or I say properly, the easiest way is you look at the first graph here and you notice, oh, it goes as far left as 0, and I want to make sure it's 0 included. You press Control-T, and at 0, you can see, my calculator's just messing with me today. At 0, 1, you can see it's a real number, so it's defined there. And so we could say that it's a bracket. So on this original up here, the domain is from 0 to infinity, and the range was from 1 to infinity. And notice how on the inverse, the domain range switched because an inverse switches x's and y's. Domain's x, so this becomes the y. Range was y, so this becomes the x. So there's our restricted domain here. One more way you could have done that is by graphing this first one, and then just looking at the table like we were doing a second ago, and switching all x's and y's. So I could start here. Sorry, this thing's just going crazy. I could start here and start switching x's and y's. So when my x is 0, my y is 1. Well, that means when my y is 1, my x would become 0, like when you switch them. So notice over here, when you see this x value 1, this provides a y value 0. That's because it switched to these two right here. So when we had 0 and 1 originally, that became on the inverse 1 and 0. So that's how this would work off the table.